All right, so for example, 422, the second example and the third example. So example 2 says the principal at Park High School records the total number of students each year. The table below shows the number of students for each of the last 8 years. So there's your table. It says create a scatter plot showing the relationship between the year and the total number of students. Show that the function f of x, y equals 600 times 1.05 to the x power is a good estimate for the relationship between the year and the population. Approximately how many students will attend the high school in year 9? So I've gone ahead and done the dot plot, scatter plot. So I basically plotted the points that were there. You can see it kind of looks linear, but they're saying that it could potentially be an exponential. So we're going to graph it and see if we can figure that out. So they were nice enough to give us the equation. So what I'm going to do is use my table key and my calculator to check it. So y equals, and that is going to be 600 parentheses 1.05 to the x power. Okay, hit enter, start at 0, and there we go. All right, so there's your table. Now, in order to compare this accurately, what I'm going to do is plot those points. Okay, so I'm going to have to use my graph here. So we have 0, 600, which we will skip that one. 1, 630, so that's exactly in the same spot. 2 is 660. 3 is 694, so basically just under 700. Oh, 694, sorry. All right, and then 729. And I'm going to skip down a little bit. When I get to 8, it's 886. So that's going to be here. So what we end up with is the exponential really looks linear. And the reason it is almost looking linear is because we're at a point in that graph where there's not a lot of curve happening. And that's partially because the base is 1.05. It's not doubling or tripling or something large like that. It's just like a 5% increase every time. So that it tends to have a little bit of a linear look, even though they're saying it's exponential. So in order to the last question where we check the 9th point, right, year 9, we basically just want to use our calculator and estimate that we're going to get about 930 students. Okay, actually be 931. So year 9 is approximately 931 students. Okay, and that's based on the equation that they gave us, not based on the graph. Okay, all right, so moving on to example 3. Example 3 says the weights of oranges vary. Maria wants to come up with a way to estimate the number of oranges given a specific weight. She weighs oranges and records their weights in the table below. Create a scatter plot to show the number of oranges and the weight in pounds. Is the function y equals 0.6x minus 0.5 a good fit for the data? Maria has a bag of oranges that weighs 2 pounds. Approximately how many oranges are in the bag? So again, we've already plotted these points. As you can see, I went up by 0.5 on the y, and I went out counted by ones on the x's. So we're going to go and do the equation that they suggested, which was 0.6x minus 0.5. Ooh, I missed my x. Okay, and what we want to do is we want to see if that is indeed a good fit for this data. We should start at 0. I'm not going to plot every point. I'm just going to plot a few of them. So again, just double checking here. 0.6x minus 0.5. So points to look at. 1 is 0.1. 2 is 0.7. And then I'm going to skip out a little bit and do something like let's do 5. It's not necessary to do every single point. 5 and 2.5. That's there. And then we'll do 10, which is 5.5. And what I'm hoping you're going to see is that, for the most part, this is indeed a pretty good representation of the data. And the reason is that it goes right through the middle of all the data points. Okay. If it did not go through the middle of data points, then it would not be a good representation. So, is it a good fit for the data? Yes, it is. Okay. If you have 2 pounds, then approximately how many oranges would that be? So I want to look at my equation and say, okay, when my equation is 2, right? Because this is pounds and this is the number of oranges. So at 2, we are roughly at 4. Okay, so 2 pounds is roughly 4 oranges. So 2 pounds is roughly 4 oranges. All right. And that's how we do 4.2.2. So again, while I'm gone, make sure you're focusing on 4.2.1 and 4.2.2. If you get done with both of those and want to move on to 4.2.4, there are no Walsh for 4.2.3. Just keep that in mind. If you want to go ahead and go on to 4.2.4, that's perfectly fine. Just you'll only have notes, no videos. Okay. Again, text me or email me if you need me. Good luck.